Excellent work on the CFU. If you did make a little mistake, this is what these are for, just to figure out, where your mistakes are. I will say the CFUs in this unit, there's going to be 3. So you have one for the next couple days. They're very short. Next one is 1 question. I think the third one is maybe 2 again. They're more skill-based. So for instance, in the 6.1 notes, we did some problems that were let's just look back at the notes real quick, just as a quick refresher. So we did adding and subtracting. Those are pretty straightforward, but we would give you ones that would say in words what to do, or subtract this from this. The practice has a question that says find the difference. What does the difference mean? Subtract. Now, if it says find the difference, you just go in order that the problem gave you. But the subtract this from this, you do have to swap. So, again, there is ways to make it, a little bit more complicated. We did these, which were good. We put stars by those. This is in the practice. I think she used, instead of f of x and g of x, I think she called things a and b or whatnot. And then the multiplication, you had one of those on the CFU. But then the other thing that we did, the last thing, was the writing. And those were writing equations. Those were the ones, this was not on the CFU, but, keep shaking that. This was not on the CFU, but it is going to be, pretty much everything in this unit is going to be on the test because it's pretty short. But writing equations given the roots, that was in the practice as well. So those needed to be y equals, and then they involved multiplication. So just refresher, your test isn't until next week, but the next couple days we're not really going to be doing these skills again. So, just don't forget, especially because you guys learned it way a long time ago. Okay, so that is there. But back to the calendar. So you see, we're going to learn long division today. It's another skill. It is tedious. It's not hard to do, but it takes time and it's a lot of steps. But the steps are easy. So give me a few problems. I'm going to try to get through 4 or 5, and then you'll have some to work on in your practice. Your required practice only has 4 homework problems today. I will be doing a homework check on Thursday, and what's expected to be done is 6.1 and 6.2. It's 13 problems total. So I'm expecting that to be done with work, okay? The 6.1 doesn't require a whole lot of space, but 6.2, long division, will require a fair amount of space, so have paper for that. You'll have a check for understanding after the homework check over long division. And then after that, I'm going to teach you a different type of division, which is much quicker and faster. It's just you can't use it every time. And we're going to talk about some theorems as well. Next week, we'll do our final lesson, which is not actually in the notes packet. Didn't make it into the notes packet, but you will have a copy for you on Monday. And then review and test. I think I said this before on Friday. I'm sure I did. But this test is worth 3 separate grades. Okay? You have 4 grades in right now, and this is worth 3. Algebra-wise, I think this unit is, skill-wise, is much easier than all the quadratic stuff. So I still haven't even passed back the Unit 5 tests. I'm more than happy to get that out and help go over it with you, in tutorials or end of class or whatever. But I kind of feel like I don't really want to do a whole lot of past test stuff until after we finish Unit 6, because we still have almost 2 weeks before those reassessments. So if you're retesting anything from Unit 5 or Unit 6, let's just hold off on that, and we'll really be able to schedule tutorials in these next 2 weeks before those, because I want everyone's full attention to be on Unit 6. Does that make sense? Just because it's 3 grades, and 3 good grades can really, really help you out if you're in a situation that, you need it. So, does that make sense? Everyone got it? Test is next Friday, so it's going to be here soon. And here we go. Long division. Are you ready? No. Well, get ready. It's super fun. Just kidding. It's kind of terrible. But it's not that hard to do. It's just, it's tedious. I said it's tedious. It doesn't mean that it's hard. It's just tedious. Do you know what that means? It's time consuming. Okay? That's why it's called long division. Okay? All right. So, well, you'll be able to see it versus the other one, and you'll know what I'm talking about. But here we go. We're just going to spend 2 days on dividing. 2 days. We will do a little bit of extension, and you'll kind of start to see where I'm going with that in the extension. We won't really get to it today, but we'll kind of talk about it in this lesson. But today's process, again, it's a lot longer than the other one. However, you can use long division every single division problem, no matter what. The other division only works sometimes, and we'll discuss that next time. So here's steps, and the steps are, I'm just going to kind of really talk about the first one, and then you'll see the steps in some examples, so all that reading is whatever. But first thing is, and this is an important step, and we really will see it today, but not until the end, but it's very important for the shortcut division, which you'll learn next time, that you do this. So it says that you need to first rewrite the problem if, making sure that your degree goes from highest to lowest. So we talked about degree last time. That's the highest exponent. And when we put stuff in standard form, we always want to go in descending order. So highest exponent to the lowest. Now, when you do division, you have to make sure that every single exponent is accounted for. Like, for instance, if I had 4x to the fourth plus 2x squared, what is missing between the x to the fourth and x squared?
0, x third.
And x to the third. In addition, subtraction, multiplication, we don't really care. But when you do the division processes, you need to make sure that you would write that as 4x to the fourth plus 0x to the third plus 2x squared. And technically, I would need to keep going. Plus 0x plus 0. You have to go all the way. Everything has to be there. If it's not, you want to put a 0 with it. And go ahead and put that exponent. It has to all be accounted for. And again, we'll see it at the end of today, but it's a really big deal with synthetic division because you will have no idea that you miss it. So I'm going to check for it every single problem, but that's how you would want to set it up. And then, again, these other steps, like I'm going to teach through those, so I'm not going to read them to you. But a couple ways you can see division problems. It could say find the quotient, because what is a quotient? The answer to a division problem, okay? What's a sum?
Addition.
What's a difference? What's a product? What's a quotient? Division, okay? So they can say find the quotient, and they can write it like polynomial, like the actual division symbol that we really never use anymore, but it's in this unit. And then the other one, they could also write it as like a fraction, x to the third plus 3x squared plus 3x plus 2 over, because fractions are division. You can write it like that. Or it can be kind of like number one. What's the result when you divide this by this? Or divide this by this. There's just multiple ways you can see it. But I do want you to know some vocab here, because I'm going to be using this vocabulary. So the first one is dividend. So dividend is either the polynomial on the top or the polynomial on the left of the division sign. It's typically going to be the higher power, higher degree, and that is your dividend. It needs to have no missing terms, so you would put zeros in if needed. And then your divisor is what you are dividing by. So it's the guy on the bottom of the fraction or to the right of the division sign. Divisor is what you divide by. It should be a lower degree there. So here's a worked out long division example for you so you can kind of see what the process will look like and why it takes, there's like multiple levels to it. So you kind of have like a level here, and then how you get your actual answer. I'm just going to jump right in to a first problem instead of like talking through that because I think it's easier just to have it not written out, but you can go back and look at that. So the first thing is, number one, I'm trying to find what's the result when x squared plus 5x minus 14. Are there any missing terms? Look at the exponents. No. 2, 1, 0, we're good. It's divided by x minus 2. Are there any missing terms there? No. It goes x to the 1 and then x to the 0. So this is your dividend right here, the quadratic, and this is your divisor, okay? And this is, what kind of factor is this divisor? If this is a quadratic, what kind is that? What? Well, it's a binomial, yeah, but this is degree 2, so it's a quadratic. What is this? Degree 1, so it's linear. It's a linear factor, which I will be talking about that next time. This type of problem could be done with our other division that we're going to learn later because it's linear. Okay, so here's how you set it up with long division. You put your divisor on the outside, again, putting any zeros if needed, but it's not in here. And you have your little house, and then you put your dividend on the inside, x squared plus 5x minus 14. Okay, so again, listen to what I'm saying, write it down. It might take a few problems for you to kind of really catch on to what is happening, but I really want you to look at what I'm pointing at, and then really it's 3 steps, okay? Every single time, and then you start the same 3 steps over. So put everything in the little division house thing, good to go. So when I start, I do a little side work over here, and you don't have to do the side work. You can do it in your head, but for now, let's write it together. And on the side, I'm going to take the first term of the dividend, which is x squared. Don't really care about what follows it right now. And I'm going to divide that first term by the first term of the divisor, because that's all I really care about for my first step. So it's a little miniature quotient I'm going to do to the side. So what is x squared divided by x? X. Why? Well, your coefficients are both 1. So coefficients divide. 1 divided by 1 is 1. How do you divide with exponents? You subtract. And what is 2 minus 1? 1. Okay, so really it's 1x to the 1, but we're just going to write it as x. Now, when you get that little miniature quotient, this guy's going to go up on the house. And I kind of put it in line with the term, this is an x to the 1, but that doesn't really matter. That's just how I line it up. And so I put that up there. Okay, so we do a little mini division to the side. Not bad. You can divide numbers. You can subtract exponents. Put it at the top. Here's the step that is the most work. And again, the work is not hard. But this is the step that people tend to mess up if they make a mistake. Then you're going to take the guy at the top, this little mini quotient that I got over here. And he's going to multiply to all the terms of the divisor over here. So x times x is x squared. Negative 2 times x is negative 2x. Now, technically, okay, because that's a process. It's just what you do in division. You multiply it, okay? Really, you are subtracting this little expression right here. So I'm doing this in 2 steps. Normally, I do this in 1, but I need to explain it to you first. So if I'm taking this expression away from this dividend, what kind of x squared is this going to end up being? If you distribute in that minus sign, this ends up being a negative x squared, and this negative 2x ends up being a positive. Now, from here on out, now that I've explained what we do, I change the sign in my multiplication in 1. Because distributing that minus sign is something that people forget. But that's technically what's going on. You multiply from the top to the side, and then you subtract the term. But then it ends up becoming a little addition problem in here. Okay? X squared plus negative x squared is what? 0. That first term always should go away. If it does not, you've made a mistake. 5x plus 2x is 7x. And then I'm going to bring down 1 term at a time. I only have 1 left. But if you had more, you're just going to drop down 1 term at a time. And then you start over. This is now the first term, 7x. And I divide it by this same first term, x. What is 7x divided by x? 7. So this little mini quotient, which is a positive 7, goes at the top. Plus 7. Okay? It keeps going. So now I'm going to, now watch how I do it. I call it multiply and flip. I'm going to multiply and I'm going to flip the sign. I'm going to take care of the distributing of the minus in 1 step. So 7 times x is a positive 7x. But then I'm going to flip it and make it a negative 7x. Because you have to subtract it. I'm taking care of the subtraction in 1 step. 7 times negative 2 is negative 14. But when I flip the sign, I'm going to write a positive 14. And then I'm going to add. What happens to my x's? They should always zero out. What happens to my constants? They also zero out, and that's great. There's no more numbers to bring down, so I'm going to put a 0 right here, and I'm done. When you run out of things to bring down, that's how you know that you're done. What's left over, this guy right here, is called your remainder. So if your remainder is 0, then that means it divides evenly. Yay. What that also means, this is kind of extension with where we're going, if the remainder is 0, then what you are dividing by, the divisor, is a factor of the dividend. And the quotient is also a factor of the dividend. If the remainder is not 0, then it's not a factor. That's what we're getting to. So we're going to be using this to help us factor. Look forward to Thursday. So my answer, my quotient, what I would put right here in the answer blank, which I am drawing for you, it could say find the quotient, it could say simplify, it could say whatever. It comes from what's at the top of the house. So what is the quotient of this problem? X plus 7. And that's all it is because the remainder is 0. So here's our answer. We've done one long division problem. Okay? So that is the process. Can it go on for many levels? Yes, it can. Is there a lot of room for mistakes? Yes, there is a lot of room for mistakes. So just take it slow and check your work. The mathematics behind it is not crazy. Okay? But it's long division. It's not the shortcut. All right, let's try one with a remainder. Number 2. Kate, you good? Good.
What does R and B stand?
I'm going to go over that. Don't even look at that right now. All right, so what is the result? This is how it used to be written in Delta Math. I'm going to explain what this means in a minute. It says, what's the result when x squared minus 2x minus 48? That's our dividend. Are we missing anything? Are we missing any powers?
No.
2, 1, 0. Okay. Our divisor, x minus 6. Are we missing any powers there?
No.
No. So go ahead and set it up. X minus 6 goes on the outside. X squared minus 2x minus 48 goes on the inside.
It works every time.
Whatever. Okay, so here we go. Let's start over. There's going to be a remainder on this one, so we need to talk about what to do with it. First term, x squared divided by first term, which is x. X squared divided by x is x. Yay, put it at the top. All right, here's the set that everyone, if they make a mistake, it's usually here. Multiply it and change the sign. X times x is positive x squared. We're going to write negative x squared. Negative 6 times x is negative 6x. We're going to write positive 6x. It's not hard to do. Just make sure you're careful. Add them up. X squareds, goodbye, as they should. Negative 2x plus 6x is positive 4x. Bring down one thing at a time. I keep saying that because you're going to have multiple things on the next problem. One at a time. Start over. First term divided by first term, which that bottom, what you're dividing by over here is going to be the same thing every time. So 4x divided by x is multiply and flip positive 4x, right, negative 4x. Negative 24, right? Positive 24. All right, go tell me how to do number 5. Go do number 5 your way.
No, he does it the same thing. He just skips the cancellation part.
Then it's not different.
It's not. He just isn't showing his work.
Okay, so what happens here? Negative 48 plus 24 is what?
Negative 24.
Negative 24. And there's no more numbers to bring down, so I'm done. So you have a remainder here, and we're going to talk about that. If the remainder is negative 24, then is x minus 6 a factor of x squared minus 2x minus 48? No, because the remainder is not 0. That's something you're going to learn next class. Now you already know it. Congratulations. Now, here's how you write it, and that's back to this thing that looks kind of crazy. So when you have a remainder that's not 0, you will write it as q of x is what's at the top of the house. R of x is the remainder, and b of x is the divisor. So here's how it's going to look like. You're going to have your quotient here, and here's your answer blank. And you're going to write what's at the top, x plus 4, plus the remainder is negative 24. You could put a minus. I always put plus and then negative, but you could put a minus sign right here, over the divisor, which is x minus 6. Now, and that's the answer. It looks kind of like if there's a remainder, it looks yucky and your answer, but that's how you do it. Remainder over divisor. Your remainder can be a number or an expression. By the end of this, we're going to see some that your remainders are like expressions. They're more than one term. So that's possible as well. Okay? So, try number 3. Yes. Because we've just got a few more to do. All right, number 3. Here was number 3. Okay, I want to tell you, so number 3 had kind of more steps. You had to go over and do the little side quotient thing 3 times. I can preview a question and know that it's going to take me more layers if you look at how far the degree is between the dividend and divisor. So in number 3, we had a degree 3 divided by a degree 1. So those are 2 apart, which means I'm going to have more steps here. The ones we did before, you were dividing a degree 2 by a degree 1. So those are going to be less steps the closer they are. So it just kind of gives you an idea of what's going on. If you did number 4, here was the work on number 4. It was a trinomial that you were dividing by. So it was a little bit different, but there was no missing terms. So you still set it up the exact same way. Dividend on the inside, divisor on the outside. You do the little division on the side. The only thing that's different about this is when you do the multiply and sign flip thing, you have 3 terms because there's 3 terms in the divisor. This is an example of a problem that you would have to use long division on because the divisor is what kind of number? Trinomial. It's a quadratic. It's degree 2. So I will make you have to do long division on your test by giving you something that's dividing by a quadratic because that's the only option that you have. Okay? Number 5 is another problem that divides by a trinomial. We're going to do that one together in case anyone is confused on what to do. We're going to check the powers here. So my dividend, check the exponents. 4, 3, 2, 1, 0. Don't need a placeholder. That's coming on the next page. And then the divisor, 2, 1, 0, don't need a placeholder. So set it up. 2x squared minus 3x minus 2. There's a lot of terms. But since it is a trinomial on the outside, it doesn't take as long. Oops, x plus 10. To do this one. I did like the division, the side division with these because it's actual like numbers now. So what's your first step? What are you dividing off to the side? Which again, you don't have to write this down if you can do it in your head. What are you actually dividing here though? 8x to the 4th by 2x squared. Just to review because we haven't done a lot with coefficients. You divide the coefficients. So 8 divided by 2 is 4. You subtract the exponents. 4 minus 2 is 2. Yeah.
What was the answer to 4?
X minus 3. There was no remainder.
Yeah.
So I get a 4x squared up here. Again, I'm going to multiply and flip the sign. So positive 8x squared, 4th, right, negative 8x to the 4th. Negative 12x cubed, right, positive. Negative 8x squared, right, positive 8x squared. And again, you just have to be really, really careful. One small mistake will derail everything. So just take your time. I'm not going to give you 20 of these on the test. Okay? 1 or 2 probably. So just go slow. And then again, also, I just bring down one term at a time. Like there's multiple there. I just bring one at a time so I really know like when I'm done. And then start over. Negative 4x to the third divided by 2x squared. Watch the sign here. What is that? Negative 2x. Especially when that number on the top is negative. You really got to watch your signs. Negative 4x cubed, right? Positive 4x cubed. Positive 6x squared, right? Negative 6x squared. That's probably why you thought double flip there.
Yeah, I think I double.
Yeah. And then again, negative times negative is a positive, but you're going to write a negative 4x. Goes negative 10x squared plus 15x. Drop it down. Squared divided by 2x squared is 5. Squared. Positive 15x, negative 15x. Positive 10, negative 10. And don't let it freak you out because it says if there is a remainder, that doesn't necessarily mean there's going to be. There is not in this case. So your answer would be, and hey, FYI, I circled up here. This is not how I want you to write your answer. I want you to actually write it in the answer blank, not just circling up at the top, please, especially if there's a remainder. So what does that mean?
It's a factor.
It's a factor. So the two factors of this whole dividend are the divisor and the quotient. If you multiply those two out, you should end back up with this guy. Okay? And guess what we're going to do next time? We're going to keep on factoring and get all the factors there. Okay, last 2 problems. We will do one together, one on your own, and then it is homework time, and you have 4 homework problems. What if there are missing terms? And we've been practicing, we've been checking for this, we just haven't seen it until now. And I will tell you, you're going to see it, and you're going to have to, especially with the shortcut, which I'll teach you next time, you got to watch out for it. You will catch it in long division. So I'm going to say use a placeholder. You will not catch it in synthetic division, and you will just completely get the problem wrong and not really have any idea that you got the problem wrong. So this is so important that any division problem that you do, you check for that placeholder there. Okay? So where do I need it? Let's check the dividend. My exponents. And again, I am looking at the exponents. 3, 2, 1, 0. Am I missing anything on the dividend? No. So I'm going to go ahead and write that in the house. There's nothing missing there. But the divisor goes x squared to x to the 0. So what am I missing there?
0x.
A 0x. So I need to rewrite this as x squared plus 0x plus 3. So it's dividend or divisor. They all have to be there. Okay? And let me show you, again, with long division, you would probably catch it and you could probably figure out how to work around it. But with the shortcut, next class, you're doomed if you miss this step. Okay? We don't want that. This should be an easy test. Division is going to be its own test grade, so we want to be not making silly mistakes. Process is still the same. I'm doing 8x to the third divided by x squared. What is that? 8x. So I put that at the top. And then I do my multiply to all the terms and flip the sign. So 8x times x squared is positive 8x cubed. I'm going to write negative 8x cubed. Now hang on for a second. I want to show you how if you didn't put that 0x there, pretend it's not there for a second. We made a silly mistake. 8x times 3 is 24x. What am I writing underneath? An x squared. And that doesn't make sense to have an x squared with an x. So that would be my reminder that, hey, I forgot. I need to put that placeholder. This is going, anything times 0 is going to be 0. And you don't really need to worry about the sign. But I like to put the x squared just to keep everything lined up. But it is just a 0 right there. Okay? But it at least keeps like a term so I know like what I'm adding. And then 8x times 3 is positive 24x, right? Negative 24x. So my first terms go. My second term, that adds up to be 5x squared minus 12x. Bring down the plus 10. Start over again. First term is 5x squared. Divide that by x squared, and I get a 5.
Yeah.
Positive 5. 5x squared positive, right, negative. This is going to be a 0x. I can just put plus 0x. This is going to be a positive 15. I write negative 15. So what happens here is I'm left with negative 12x minus 5. Are there any more numbers to bring down?
No.
So this expression is my remainder. So is x squared plus 3 a factor of the dividend? No. You write this the exact same way that you wrote your other answers. Here's your answer blank. And you would write 8x plus 5 plus negative 12x minus 5. Again, you could put a minus in front of the fraction instead of a plus. I just always do that. And then the divisor, x squared. You don't have to put the placeholder in your answer. You can. You don't have to in your answer. But you have to put that over the divisor. Okay?
Where'd you get it? X squared plus 3.
What you're dividing by. You could put the 0x in there, and that's okay. So, number 7, you need 2 placeholders. Where are they? I want you to do this one on your own.
Oh, I see it.
Minus 12x plus 5 over x squared.
What?
Like,
Oh, can you, on this problem, minus 12, yes, yes. So, what is number 7? 4x to the 4th plus 2x to the 3rd, what?
0x squared.
0x squared minus 9x plus 12 divided by, what's the divisor?
Minus 2x plus 0.
X squared minus 2x plus 0.
Oh, there.
Okay? All right, this one kind of has a weird remainder as well. And then when you finish that, you've got the blue homework sheet, which we all have this. Yes? Do we? You need to be done with 1 through 13. Homework check, the beginning of next class. Beginning of next class. There is no extensions. It is either all done and with you, not on your desk, not at home. It is all done and with you when I walk around with my clipboard or you're getting an academic lunch. And then we're going to take a 1-question CFU on long division, and then I will teach you the shortcut and the theorems, and life will be good, and we'll almost be through Unit 6.
Synthetic. I have a question.
Yes.
Why can we just know this?